Thank you very much for giving me the floor. So I'm honored to be here, and I'll be presenting. Let's just note that I'm not going to be telling you anything new because everybody has said so many things about what I'm going to be talking about, so it doesn't hurt to repeat it again. So we'll be looking at harnessing gene-drive technologies for sustainable malaria control in Africa. We all know malaria remains a major public health concern in Africa, especially in sub-Saharan Africa, which showed us the bulk of the disease burden. And in 2023, we still have 263 million malaria cases worldwide. And we can see from the data projected that we have 60.4 cases per 1,000 population at risk. That's really a lot. And we still have a lot of deaths, close to 600,000 in 2023. So it's from the WHO data, we see that 94% of the cases of death are in Africa. And worldwide, we have India, which is not in Africa, that really still has a high malaria burden. It's worth noting that countries like Nigeria, that used to shoulder a very big part of this burden, have been experiencing a very gentle slope from 30 to what we now see at 26. What are the current malaria strategies? Because of this burden, there's been a lot of malaria control interventions that have been put to place in countries, especially in sub-Saharan Africa. And we have 11 high burden, high impact countries that have a lot of interventions put in place to fight malaria. And among these, we have the nets, the insecticide-treated bed nets. We have indoor residual spraying. We have the development of novel control strategies. We see that we have sugar baits, we have the Wolbachia, there's so many that are still in the development stages and research phases. Then we have the larval source management. So different countries are pairing these different interventions according to their budget, to their policies or strategies put in place. It is also worth noting that fighting malaria is a multi-front initiative, and while vector control has proven to be one of the most efficient fronts to fight malaria, there are other tools like the medication or the drug therapy, and also the vaccines that was talked about earlier today. So among these innovative tools that we can have, the burden is so high that we have to expand on these toolkit. And one of the potential additions to this toolkit is the gene-drive technology, which we have heard a lot about since we got here. So simply put, gene-drive is a technology that leverages gene editing to bias the inheritance of a selected trait that would be leveraged or used to either reduce the population of mosquitoes or modify the population of mosquitoes in a way that would support the fight against malaria. I believe that a lot has been said about how this would happen, especially by Frederick, so I'm not going to talk about that again, but I can show you here that how this is done is that DNA is continuously being repaired. DNA is double-stranded, and it can be damaged. And in the system, normally there are mechanisms where DNA repairs itself continuously. So the gene-drive technology would leverage this repair mechanism to insert the modification that we want. And it's it's a very precise technology because you use the Cas9, which is like a scissors, and then you leverage the repair to add something as shown in this figure. What would happen to this? You would have to create a construct and therefore use that construct to generate a population, the modified population that would go into the wild or in the ecological system and either crush the population or modify it so that the new mosquitoes that will be in the system won't be able to transmit malaria. What are the potential benefits of this kind of technology? We can start by talking about sustainable control. Because we are able to determine the kind of modification that we make, we are therefore able to control how sustainable this can be on the long run. This can be done either by multiple releases, and there will be strong monitoring and evaluation, which would ensure that this would achieve its expected outcome within the time frame that has been decided. Also, we can talk about scientific advancements that have been done in this field. I didn't want to go on a long history of what is happening, but I would just like to talk about the Target Malaria Consortium, and that has already been mentioned. So here we have a lot of the work that have already been done by Target Malaria, and as Jonathan said, it's still at the development phase, and so many publications are available for those who are interested on the Target Malaria website. There's a lot of information on progress that has been made and the potential constructs, species. This technology, we all know, build capacity around this technology. Not only build capacity, but share knowledge, so educate people on the existence of this technology. And because or technical, there's no need to build an entire framework around how this technology can be down or simplified to make it understandable to all different stakeholder groups. So there is the to build this capacity and also capacitate African institutions on how they can own this technology and use it to solve African problems. And among this capacity, there's the component of engaging the communities. We have seen today that the end users of this technology are the communities, the people who shoulder the burden of malaria. That's our grandmothers and those that live in the rural areas, for example, and these people don't have enough education usually to understand the complexity of this technology. However, they are the main beneficiaries of this technology, should it be adopted. So there's a need to go to these people and explain to them that there are other options that can be used to eradicate malaria. So the stakeholder engagement has to be done at various levels, starting from the top with the policymakers and right to the bottom with the lay people. And this should be part of the strategy or the plan right from the conception of the project. And as we have seen, stakeholder engagement is now has always been a very important part of the project itself. And Target Malaria is doing a lot of great work already on the stakeholder engagement, as we can see in the example, the picture here. Also, another very important component we've seen earlier is the regulatory framework. And according to me, that's the bottleneck in the whole chain of the procedure, because there's a lot of work required to develop the appropriate regulatory framework to support such a technology. However, it is, on the bright side, there is a lot of progress that has been made, as we can see from the level of the Elder NEPAD, and there's a lot of guidelines available for countries to use to adapt their own national guidelines from them. These are a few examples of these publications by Elder NEPAD. So we're still looking at on a global level, because most people we talk about gene drives, but in the context of malaria, I would like to highlight that we can have gene drives being used in other domains as well. So if a country is interested in adopting gene drive, it won't be just to eradicate malaria, but it would also find potential uses in a lot of different applications. And we can see that in agriculture, in environment, in animal welfare, and of course in health, as is the case for malaria. So this could be a way to make the packaging more appealing and letting the government know that they can use this to solve a wide range of problems that already exist in the different countries. One also very important point is the ethical and ecological considerations, and I'm very happy that we just had all these different answers from Frederick, who has really given us more insight on the level of work that needs to be done to be able to put to rest the ecological considerations and the ethical considerations. So we can see from this diagram how complex these considerations are, and at every level these answers need to be provided. And so we look at the uncertainties, what we know, and also we need to estimate or measure the level of unintended consequences. And this would take a lot of different tests and trials to be able to answer enough of these questions to reach the threshold required for the ethical and ecological considerations. So we have some publications as well on this, and even interconnecting them with the environmental impact, as we can see with climate change. Okay, as I said earlier, my bottleneck personally is at the regulatory framework, and I think that this kind of technology needs a very robust regulatory framework, and there's the need first to build capacity on what kind of regulatory framework is needed for this kind of technology. And I'm very happy to see that there are organizations like, or consortium like the Genetic Biocontrol Consortium that is already doing that great work that is needed to start building these frameworks. I would also like to add that there's the need for that regional collaboration, and that's something that has already been initiated, as we can see with the different NBAs that are represented at this Congress. So it's a work in progress and in the right direction. We also have to continue talking about community engagement and public perception of the technology. Due to the complexity of this technology, it has to be a continuous process, and it has to be done at multiple levels using different tools, even the innovative tools like the social media in this case. So we can see that the community engagement part of the work, for example, we talked about the African conversations that has been taking place under the work by Lina Finda in Tanzania. That's a great initiative that brings different stakeholder groups and assess their perceptions so that they can, their worries can be put to rest. So there's a need to continue engaging the community, and this can be done by bringing the benefits of such a technology to their livelihood, using their local experts, and I really appreciate the fact that this is already being done with African institutions, putting in the forefront people that they already know and people that they trust to explain these different technologies to them. And the capacity that is being built in the research space is something to also comment, because we have a lot of African researchers already building capacity in this very innovative technology. So what does the future look like for this technology? We're still at the research level, so it's about continuing the research and scaling gradually towards contained trials, either by using larger cages or semi-field conditions. I think these are at different levels depending on the regulatory approvals that are already being made. But as my colleague said, there is really no gene drives already released in the field in Africa anywhere. Of course, to be able to harness this technology, there is a need for responsible development. Responsible development, and this has to do with the approvals, the regulatory framework, and how this technology is going to be developed and used. For what purpose is it going to be developed and used? And here we have to rely on strong ethical and regulatory frameworks that will be able to ensure that this technology is used exactly the way it's supposed to be used, or that the adoption of this technology has all the different components that will ensure that it is very safe, that it is very well monitored, and that the impacts on all the different, be it ecology, environment, and human health, even animal health, are all taken into account. This, of course, will be done by the different, at the country levels. As Fred just said, we think we already have the setup to be able to get that scale up and maintained. In conclusion, I think that gene drive technology holds a very significant potential for malaria control, given that it will be able to cover the gaps that exist in the current strategies that are being deployed, especially when it comes to cost and also the new vector Anopheles stephensi that bites outside and during the day. It has a potential to solve malaria in Africa if properly used, as we have discussed earlier, and it could effectively harness, we could effectively harness this technology if the capacity is built and accompanied by the infrastructural and development. Stakeholders at all levels should be able to be included in this research so that they can support as much as they can. And we have some different publications that exist in case we are curious to learn more. And with that, I'd like to say thank you.